Hello, this is a follow-up video for solving equations that involve logarithms. So we'll be using logarithm properties as well as checking for extraneous solutions. So there are extraneous solutions that sometimes come up when we're solving logarithms because of the fact that a logarithm has a limited domain for what can go into a logarithm, that the domain is generally going to always be positive values inside of the argument. Again, the argument is what is inside the parentheses. So the first example that we're going over is log base 7 of 5w plus 14 equals 2 times the log base 7 of w. And so I happen to see that these are both log base 7. And so because of that, I know that I'm going to be able to solve this problem. But the first thing that I need to do in order to make this problem easier for myself is to use the power property of logs to bring this squared up to the top. And so when I do that and then I rewrite what I have left, I've got again log base 7 of 5w plus 14 equals log base 7 of w, and now this w has been squared. So now that I see that I've got, again, a log base 7 equaling to another log base 7, what's inside of the parentheses, these arguments must be equal to each other. So now I can just set them equal to each other. When is 5w plus 14 equal to w squared? That's what I need to solve, because that will tell me these situations for when the left and the right hand side are equal. I happen to see that I have a quadratic equation because of this w squared. So I'm going to go ahead and make sure it equals 0 so that I could use a tool of factoring in order to solve this problem, or potentially quadratic formula. So moving everything to one side and rewriting, this is the same thing as w squared minus 5w minus 14 equals 0. And I see that this is going to be factorable because 14 has factors of 2 and 7. And if the 7 is negative, that will allow us to add to a negative 5, yet multiply to a negative 14. So again, here we've got w subtract 7 and w plus 2, because negative 7 and positive 2 add to the middle term and multiply to the constant. Using zero product property, either w equals 7 or w equals negative 2. So as you see how math builds on math, you got to know how to factor a quadratic in order to solve some of these problems involving logarithms. So here are my two different solutions. It's so important to always check our solutions, though, because as a reminder, we're going to check our solutions because our argument for a logarithm cannot be negative. So let's go ahead and check the value of 7. So in the original problem, if I check this value, again, we've got log 7 of 5 times, again, we're going to evaluate the 7 plus the 14, and we're wondering, does that really equal 2 times the log of 7? And so simplifying the left-hand side, log base 7, this is 35 plus 14, and I'm really wondering, does that equal 2 times the log base 7 of 7? And the cool thing here is that because the log base and the arguments are actually multiples, because if I simplify this is log base 7 of 49, I can actually evaluate this without using a calculator. So if I think about what these answers would be, on this side here, again, the answer to a logarithm is what power do you raise the base to get that answer. So here it is 2. And over on the other side, we've got 2 times, and again, right here, evaluating this, 7 to what power gets you to a 7? That's just 1. And so this really does say that 2 equals 2 times 1? Yes, it does. So that solution is valid. Let's go ahead and check the other solution. So let's check the value of negative 2. So we've got, again, log 7 of 5 times negative 2 plus 14. Does that really equal, again, 2 times log of -2. And right away, I immediately see that I have got a violation of the domain of a logarithm. So right here, this is an error. This, again, is no solution. There is no solution here. Because that, again, I forgot that I dropped my base. But this is saying 7 to what power gets you out of -2? And as a reminder for all exponentials, which grow kind of like this, they never have outputs that are below the x-axis. And this is saying the output, when is the output -2? The output is never negative. And so there is no solution. So therefore, the w equals -2 is extraneous. My only solution in this case would be w equals 7. So this is my only real solution. The other solution of -2 would be extraneous. Please watch the follow-up video to this lesson for solving equations with logarithms, but it will be with a natural logarithm.